Welcome back. We're going to be talking about direct variation now. And direct variation is simply a line that goes through the origin on a Cartesian graph. The direct variation equation is simply expressed as y equals ax. It can also be expressed in more scientific terms of y equals kx. And you can see it either way. This represents direct variation. You can see there is no plus b, like a y-intercept, because it does go through the origin. So it's always going to go through 0 on the x and y axes. The term in front, the a, is not, we kind of get away from calling it slope when we talk about direct variation. The term in front, being the k or the a, is called the constant of variation, and that kind of determines how, well, it does essentially the same thing as slope does, determining the slant of the line. So here's a couple graphs. Y equals 1/2 x. Here's one that has goes up kind of like a positive slope, or y equals negative x is also known as direct variation, but this one's heading down. Let's look at an example here. We're going to write and graph a direct variation equation that has -3 and -9 as a solution. So we said it's y equals ax, or y equals kx. And our x value here is -3, and our y value is -9. What we need to know what a is. What is our constant of variation? And we can find that by substituting in our -9 and our -3. So now we just solve for a. So I would divide by -3, and thus a would equal +3. So our equation of direct variation is y equals 3x. And that graph would go through the origin, and then we would go up 3 over 1, up 3 over 1, and up 3 over 1. Connect those points. Let's see how well I do. That way and that way. And of course you would be using a straight edge and make your points look nice and clean. And don't forget your arrows. Let's see if I can get one down here. Okay, so that's how you can find it if given a point on the line, and you can graph it with that. Okay, let's look at a second example, an application problem. Hooke's law states that the distance d a spring stretches varies directly with the force F that is applied to it. Suppose a string stretches 15 inches when a force of 9 pounds is applied. Write an equation that relates d to F. So we know it's direct variation. It tells us. That's nice of them. Real life isn't like that, so we had to figure that out. But for our purposes, we know it's direct variation. So we can start off with that. We're going to be using the y equals ax. So let's define our variables. We're going to say let d equal distance, and we're going to let F equal force. So we're going to substitute in D and F in this case. But we have to ask ourselves, which one is independent and which one's dependent? Does the force depend on the distance, or does the distance depend on the force? Since the distance of the string or the spring is going to get longer as we put a heavier weight on it. And if it's a lighter weight, it won't go down as far. The distance of the spring does not affect how heavy the weight is. Okay, you don't stretch it and then suddenly the spring gets, or the weight gets heavier. You put on a heavy weight and that stretches out the spring. So in this case, the distance is dependent, so it's like the y, and the F is independent like the x. X is independent, y is dependent. In this case, F is independent and D is dependent. So we'll write this as D is equal to AF, or DAF. So the distance is 15. We're looking for the constant of variation, and 9 is the force. So the constant of variation is equal to 15/9. So our equation is D equals 15/9 F. And we would box that in. Okay, now let's say we want to predict the distance that the spring will stretch when a force of 6 pounds is applied. So we would write this out. Our equation was D is equal to 15/9 F. So now we're just going to substitute in the 6 pounds of force for F. So D is equal to 15/9 times 6. So thus, our distance is going to be 10. So we write, therefore, the distance the spring will stretch is 10 feet. Okay, so in our last example, we want to tell whether the data in the table show direct variation. If so, write an equation relating x and y. One of the unique features of things that vary directly is that they are proportional. The y is proportional to x for each iteration. So if you look here, I can determine by looking at these ratios. So if I'm going to compare y to x, like we do just like with slope, for the first one of -1 and 3, it's going to be -1/3. And if I look here, on the next one, it's going to be -2/6, which is also -1/3. -1/3. And each one of these, when we test it out, should equal -1/3. So -3/9 is equal to -1/3, and so forth. And this -1/3, this ratio, happens to be our constant of variation. So therefore, our constant of variation is y equals negative 1/3 x. And that's one way you can figure it out. So this concludes direct variation, and I hope you learned a lot out of this. Thank you very much.